Hello students, we have discussed about the Coulomb's law in the previous video. Now we are discussing about representing the Coulomb's law in vector form. The benefit of representing it in vector form that is there that it helps us to correlate it in accordance with the Newton's third law of motion, that is, to every action there is an equal and opposite reaction. So see here Coulomb's law in vector form. We had got that the force between two charges, it was identified to be F equals to K Q1 Q2 upon R square. Now we consider that this is charge Q1 at point A and this is charge Q2 at point B. The distance between the two charges is R. Now we know that force is a vector quantity. On right hand side, K is a constant, but Q1 and Q2 are charges, but these are scalars. So only quantity which on the right side is a vector is this distance, that is R. So we can represent F in terms of vector by converting R into its vector form. So first we discuss here the force on charge Q1 due to Q2. We represent it like this, that force on 1 due to 2, that equals to K Q1 Q2 upon R square. We multiply it with a unit vector 2 to 1. Remember, when we are finding the force on Q1 due to Q2, so we are taking the distance from the effecting charge Q2 to the effected charge Q1. That is distance from 2 to 1. So distance from 2 to 1. Now you all know that if a magnitude is multiplied by a vector, unit vector, it changes into a vector. So we can very comfortably put here a vector sign. So force on 1 due to 2 is K Q1 Q2 upon R square, unit vector R 2 to 1. Now as we all know that unit vector can be taken as vector upon its magnitude. So therefore vector cap R21 can be taken as vector R221 upon its magnitude. Now the magnitude of vector AB is simply R, so we can take it as R21 upon R. So therefore force on 1 due to 2 comes out to be K Q1 Q2 upon R square into vector R21 upon R. So thus force 1 to 2 comes out to be K Q1 Q2 upon R cube vector R21. This is the force on charge 1 due to 2 in the vector notation. So force on 1 due to 2 is equals to K Q1 Q2 upon R cube into vector R2 to 1. Similarly, what we can write, that force on 2 due to 1. This was force on 1 due to 2, that is on Q1 due to Q2. As the charges will be affecting each other, they will be applying the force on each other. So force on Q2 due to Q1, that is F21, can be taken as K Q1 Q2 upon R cube vector R1 to 2. Simple. Force on 2 due to 1 is K Q1 Q2 upon R cube, distance vector R1 to 2. Now distance between A and B, that is Q1 and Q2, is the same. It is not changing. The only change we have put is there R21 or R12. What is the difference between them? Here vector R21 must be equal to R12 in magnitude, but their directions are opposite. It is from 1 to 2 and the other is from 2 to 1. So we put here a minus sign. Equal magnitude, opposite direction. So as vector R21 is equals to minus R12, so thus we conclude that force on 1 due to 2 is equals to force on 2 due to 1 but opposite in direction. Means the force on charge Q1 due to Q2 is equal to force on charge Q2 due to Q1 but directed opposite. Means the forces are equal and opposite. So every action has an equal and opposite reaction. This is Newton's third law, as we know that. So Coulomb's law in vector form is in complete coherence with the Newton's third law of motion. Clear? Now yesterday we had discussed here about this term K, and we had discussed that K is what? 1 upon 4 pi epsilon naught in SI and also in air or vacuum. Remember that epsilon naught we had discussed to be known as absolute permittivity. So now the topic of the concern is dielectric constant or relative permittivity. First, what do we understand by the term absolute permittivity? The absolute permittivity refers to that extent to which the charges can push or pull each other. That means how strongly they can attract or repel each other. This is the value of that extent in air or vacuum, which had a value of 8.85 10 to the power minus 12 Coulomb square Newton inverse meter minus 2. This is the value of absolute permittivity. The permittivity of free space, that means if the charges are kept in air, so this is that constant which determines the strength of the force. However, if we place a setup of charges in any medium, say in water, then what happens? The force between the ions become weak. For an example, we have sodium chloride. Sodium chloride, that is NaCl. It is a kind of salt, we all know, which is comprised of a positive and a negative ion. Now, if the salt is kept in open, so it is NaCl. We are not having any sodium ion or chloride ion. This in dry form cannot cause any kind of conduction. But as soon as we put this salt into water or any salt into water, so this helps in conduction. Means the ions get separated and they start conducting. How it happens? Because in water, the force between these two ions get reduced strongly and the force is not able to hold the two ions together. Sodium ion and chloride ions get separated in the presence of water, and that causes the easy conduction. So by that factor by which the force reduces is termed as the dielectric constant. The dielectric constant. Good. So how do we define that? We had discussed in air force between two charges as to be 1 upon 4 pi epsilon naught Q1 Q2 upon R square. But when they are kept in any medium, so what happens? The force F in medium is considered to be 1 upon 4 pi epsilon Q1 Q2 upon R square, where epsilon naught is the permittivity of free space and epsilon is the permittivity of given medium. If we compare these two, that is F air upon F medium, so that gives us 1 upon 4 pi epsilon naught Q1 Q2 upon R square over 1 upon 4 pi epsilon naught epsilon Q1 Q2 upon R square. In comparing, we get it is simply epsilon upon epsilon naught. If you compare, they are cancelled. 1 upon 4 pi cancelled. Epsilon goes up. So it becomes epsilon upon epsilon naught. This is epsilon r or K. This is the relative permittivity or dielectric constant. So how can we define dielectric constant? So dielectric constant K can be taken as F air upon F medium. That is the force between two charges when placed in air ratio the force between the same two charges kept at the same distance in the given medium. So in this example, K for water is identified to be about 80. What does it mean? That is, the force in water reduces by 80 times that in air. And this is quite enough to get the molecules separated. So this is how the permittivity affects the force between the two charges. So this is all about the permittivity and the Coulomb's law in vector form. Thank you.